These are the last three problems that you'll end up seeing on the study guide for chapter or for test 5, quarter 3 for Algebra B. So let's take a look at this number 7 here, and this one asks us to solve using the quadratic formula. So the important thing with the quadratic formula, which I'll write down again for you, but before I do that, the first thing you want to do is always set equal to 0. So whenever you factor or use that quadratic formula, you got to set it equal to 0. So I'm going to move this 7x back to the other side. So I'm going to subtract that. And then I'm going to end up adding the 2. So those are the first steps. Now I've got this, x squared minus 7x plus 2. And this all equals 0. So now you can figure out your a term, which is in front of the x squared. B term is the negative 7. C is 2. And so from this point, we can go ahead and use that quadratic formula. Remember, it goes opposite of b plus or minus the square root of b squared minus 4ac all over 2a. And this gives us our x-intercepts. So let's go ahead and substitute the numbers in there. So our b term is negative 7. So we're going to end up going the opposite of that. So that's positive 7 plus or minus the square root of negative 7 squared minus 4 times a, which is 1, c is 2. This is all over 2 times a, which is 1. So we go ahead and do some more work there. Underneath the radical sign, we've got 7 now, plus or minus the square root of 49, and then it's a minus 8. This is all over 2. Now minus because there's only one negative sign right here. And so when we go ahead and do the subtraction, we're going to end up with a number that's not a perfect square. We end up with 41. And that's okay. I'm just going to have you leave your answer just like this. This is called the exact form, but it is simplified because 41 doesn't have any perfect squares that we could factor out. And so that's all we'll do. Let's take a look at the next one. Here we have it already set equal to 0, so we don't have to do any extra work. 2 is the a term. B term is negative 1. Watch the sign there. C term is also negative 1. And so we're going to just take those values and substitute them into our quadratic formula, which I wrote down over here. So the opposite of negative 1 is going to be 1 plus or minus the square root of negative 1 being squared minus 4 times a, which is 2, c is negative 1. And this is all over 2 times by 2. So we do some more work there. Underneath the radical, simplify some of that stuff. So we're left with a 1. And it becomes a plus sign now because of the two negatives. You see how we have two negatives. Whenever a and c are opposite in sign, you're always going to end up adding because you'll have an even number of negatives. And then we get 8, and down below we just have 4. And so we go ahead and do some more work. It's 1 plus or minus the square root of 9 over 4, and you can go ahead and take the square root of 9, which is 3. And from there, it's all still over 4. So you can set up our two problems, 1 plus 3 over 4, and we also have 1 minus 3 divided by 4. So we end up with 4 fourths, which is 1. And here we get negative 2 fourths, which is negative 1 over 2. Those are the two x-intercepts. Well, the next problem is asking us to find three things. It talks about a ball is approximated by this equation. Find the time the ball will reach the maximum height, its maximum height, and the time in air, or time it'll hit the ground, which is the time in air. So we'll do the first one here. We'll do time to max height. And so the time to maximum height is just negative b over 2a. Now, a common mistake I saw in the last test was that there is a common factor, negative 5. You can divide them all by that. That'll get you the time in air, the time it contacts the ground, but it will not give you the same maximum height as this equation would. So you cannot simplify the equation when you're trying to find the maximum height or the time to it. And so we go ahead and do some work there. Negative b, so the opposite of that, which is going to be negative 40 over 2 times by negative 5. So we do some more work there. It just is a 40 over 10, which just makes 4. So time to the maximum height is 4 seconds. So I'll put that right here, time to maximum height, 4 seconds. And now we want to find the maximum height. Well, the maximum height is just going to be when we take that 4 seconds and put it in to this equation, solving for h in this case, which is like the y value. So we're going to take the 4 and put it in for these t values here, here, and that's it, just those two. So we have -5 times by 4 squared, and then we have a plus 40 times by 4, and a plus 45. So we continue doing some more work here. Square this number, -5 times by 16, plus, and then 4 times 4 makes 16 with a 0 at the end, and then plus 45. So again, what I had said before is that when I multiply these two numbers, I should get 80. And the reason is actually -80 because it's half of 160 and it's an opposite sign, and that's exactly what I get. -80 plus 160 plus 45. So when I do the subtraction, I end up with 80 plus 45. Do some work there, add those two numbers together, I get 5 and 12. So 125 meters. This is in, so we'll go ahead and write that down. Maximum height, 125 meters. Now I know it's in meters because looking at the equation, it's a -5t squared. This always is half of the acceleration of gravity, and acceleration of gravity is about 10 meters per second squared, so that's why I knew it was in meters. Well, the last thing is they want the time the ball will contact the ground. So what we're going to end up doing is putting a 0 in for this h. So time in air is pretty much what we're looking for here. And so we're going to put 0 in for h equals, and then here's where we could take out that common factor. Okay, we got -5t squared plus 40t, and then we have a plus 45. So again, last test, people wanted to take out the common factor when they're trying to find the time to the maximum height, or the maximum height itself. And you can't do that because it changes the equation. But you can do that when you're trying to find the time in air, because if you modify the equation, the new equation is still going to have the same x-intercepts. It's just going to be the vertex is going to be in a different spot. And so that's what I'm going to end up doing here. I'm going to go ahead and take out that -5. It'll make the factoring easier. So I do that division. I'm going to write it down here. I've got now 0, and I do it on both sides, but again, 0 divided by -5 is not going to change anything. So I got 0 equals, and then I got t squared minus 8t, and then a minus 9. And so when I go ahead and do the factoring, I end up with t, and then it's going to be a minus 9t plus 1. So you go ahead and do some work there. You set the factors equal to 0, and you come up with two answers. So we end up with a positive 9 and a negative 1. Well, you're going to go with the one that is positive right there, because negative would just be before it launched, and that's not what we want. We want after it launched, when it will hit the ground. 9 seconds is the time it takes. So notice that you can't just double the time to the maximum height, and the reason is that it started above the ground. It had an initial height higher than 0. So only if it starts on the ground can you just double the time to the maximum height. So those are the types of problems you'll end up seeing on this week's test. Good luck.